right, so let's remember, guys, when you come in, if it says read pages, that's going to set you up for success here. And it's going to set you up for success today during the lesson. So please make sure you do that reading. If the starting temperature was -5 and the change of the temperature is 25 degrees, what could be the two final temperatures? So I know I have a starting temp, right? This is where this is the number I start with. And then something happens, right? And what do we call this? What's this? The change. And what's the variable for change? N. So I'm going to put an N underneath it. And you can do that on your warm-up as well. Diego, you want to make sure you're following on your warm-up. And then I end with a temp. So what's my starting temp, Caden?
Your starting temp is 25 degrees.
Not 25.
-5.
So I start with -5. And then I have this change of 25. So let's say it's a positive change of 25. What's my end temp? Keegan?
20 degrees Fahrenheit.
How'd you get 20?
Because I took the 25 degrees and all I had to do was subtract 5 because I knew there was a -5.
So Keegan's doing this. On his number line, this is 0 if -5 is here. And he knows he's going from here. And this is positive 25. If he just takes away that, he knows how far this is, and that is 20. So that's one of the number sentences that you could have. I start with -5, I have a positive change, I get 25. But I also could have not just a positive change, I could have a negative change of 25. If I have a negative change of 25, tell me about what happened to the temperature, Kathy.
It would go down.
It's going to go down. It's getting really cold, right? So if I have a negative change of 25, talk your tables. What's this now? Go. This is cool. I was hearing Ethan say, Keegan, I heard Ethan say, hey, I'm starting with a negative, I'm adding a negative, and adding a negative is just like subtracting a positive. When we subtract positives, we go to the left, our value goes down. We get further from 0. So on the number line, if that's 0 and I'm at -5, now I'm going this way. -25. I could count that off on a number line, or I could think to myself, well, if I was at 0 and I went 25, I would end at 25. So if I add 5 more to this, I get -30. That is my other number sentence. So there's 2 different temperatures you could get, depending on if it's a positive change or a negative change. I want you to talk your tables here. I'm going to give you about 1 minute. Talk your tables. How can I predict if my answer is going to be positive or negative when I have 2 numbers? Go talk your table. What are you guys thinking over here?
I said
Cheer down. You okay?
yeah.
Okay.
It's saying like the answer. So I said just say the answer will be greater than 0.
So I heard a couple key words here, Kendall. I heard Henry over here is talking about absolute value. He was saying if one has a greater absolute value, that will be the sign. What is absolute value? Nathan?
A number greater than
Not a number greater than 0. Hawken?
It's how far a number is away from 0.
It's how far. So absolute value means how far are you from 0. So if I have two numbers, Nathan, look over here. Two numbers. I have positive 7 and I have negative 12. Which one's further from 0, Nathan?
negative 12.
So that would mean negative 12 in absolute value, that's what these mean, these two bars, in absolute value terms is greater than 7. But if I just did this, which one's greater? Jaden, 7 is greater. Because we're not talking about absolute value anymore, right? But when you talk about absolute value, it means how far from 0. This is further from 0 than 7. So this is a greater number in absolute value terms. So in absolute value terms, we get a whole bunch of algorithms. What's an algorithm?
A number sentence?
Kind of, it is. Definitely is a number sentence. Athena, I want you to make sure. I don't want you to fall behind on this, okay? What's an algorithm? Yeah, Ethan's got an idea. It was in the reading. Caleb's looking at the reading because he's like, I read this word. What is it?
An algorithm is a plan or a series of steps for doing a
Computation. So here, I'm going to put it really easy, Ariana. An algorithm is a representation, a series of steps that means something in math. I have a whole bunch of addition algorithms. So Ethan, right here, what do these bars mean again?
absolute value.
Absolute value. So this means if I have a positive number, and you notice this P, is it bigger than the N? So this has a greater absolute value than the negative. So if a positive has a greater absolute value, Diego,
Yeah.
then a negative absolute value, take us what happens. It stays positive. Even if I'm adding a negative. When I add a negative, it's like what? Subtracting a positive. So I'm going to move left. But if this is greater than that, it stays positive. This is what that means. If I'm at 0 and I'm adding negative 6, is negative 6 greater in absolute value than 8? No. 8's greater. So it will stay positive. But what do you notice about that too? In absolute value terms, is it greater than the 8 or smaller? Smaller. That's why when I have a greater absolute value in a positive, and I add a small absolute value negative, I still get a positive. But look what happens here, Jaden. If I have a small absolute value and a positive, and a greater absolute value and negative, which one's further from 0? The positive or the negative? The negative, because it has greater absolute value. It's further from 0. What happens then? Stays negative. It never quite makes it back. So if I'm at negative 8 and I add positive 6, negative 8 is greater than positive 6, so it never makes it back over the positive side. Does that make sense? It stays on the negative side. These algorithms are so helpful, okay, for you to understand how like numbers work when you add positive and negatives. So I'm going to be having this up today, and we'll look at all of them. So we're going to let's look at this one. If I have a small absolute value negative and a greater absolute value positive, which of these numbers is further from 0? Is it the negative or the positive, and why? Talk to your tables. Come on, Diego. Okay, Sky, hold on. Sky, if this is a number And I know that this number is smaller in absolute value than this positive number. Okay, what does absolute value mean again? What's absolute value? Who can help Sky out? Jaden. Furthest from 0. So the one that's bigger is further from 0. So which one's further from 0 here? Is that bigger than this?
No.
So the positive is further from 0. It has a greater absolute value because it's bigger. See how that's bigger than that? So this has more value than that negative. So it would mean, let's go to the number line. It would mean basically, let's say this is -6, and now I'm adding 8. Which one's further from 0? 8 or -6? 8 is further from 0. On the number line, if that's 0, this is 8 spaces. How many spaces is that? 6. So you can see 8 has a greater absolute value than 6. So what happens is it goes over to the positive side when I add it to -6 because this is bigger than that. So it goes over. I know that that's 6 away. So what's 6 out of 8? What's left over?
+2.
+2. I get a +2 there. So that's why when you have a small absolute value negative plus a large absolute value positive, I still get a positive number. Because this, Casey, this is greater. This is greater than that. All right, today, put away your warm-ups. Just want to go over a couple things. This is, wrong way. This is good because AJ came in and he asked me. He was like, hey, what did I miss yesterday? That's a great question, AJ, and I love that he asked me because it literally is what I wanted to talk to you about today. Briefly. When you are absent, it is your job to figure out what you missed. How do you do that? How do you do that? Nathan? Google Classroom. You guys, when you miss school, it definitely, I don't like it when you guys miss because you miss a lot in here. That's why I make YouTube videos, just like today, so you don't have to miss it. But if you do miss it, I'm definitely doing my job right now. Everything's posted on the slides. You know what you missed. You just got to go there. You can go to YouTube. You can watch me teach the lesson, Ariana, which I know you guys miss me when you're not here. Mm-hmm. She said that. She said that almost convincingly. Almost, but not quite.
Of course we miss things.
Yeah. So, but here's the deal. Missing school is not my issue for you. It's your problem, not mine. Because this is why, Ben. Yesterday, in 7th grade alone, there were 11 kids absent. So listen. Yeah, there were a lot. A lot of kids are sick. And I don't know if it's because we had, the weekend, right? And kids didn't get back in time, whatever. But 11 kids. Do you think I can remember who those 11 kids are? No, you kidding me? I barely can remember waking up in the morning. I can barely remember teaching this. So this is what you need to do. It's your responsibility. You need to figure out what the warm-up and exit ticket is. Because who's responsible for the warm-up and exit ticket?
We are.
You are. Even if you are not here, Isaac, you still have to do the warm-up and exit ticket. Now, today, I did have 17 kids. Now I'm down to 10. But 10 of you are going to be in here at lunchtime. Why? I didn't get warm-up and exit tickets. You fixed your problem this morning. That's awesome. You and a whole bunch of other kids came in. So that's being responsible. Diego know that he missed school, came in, figured out what he missed, got it down, fixed it, boom, gone. And did you get my help, Diego? Yeah. In the morning, you get my help. During class time, It's the class's time. It's not your time. I will give you help during your time, not during class's time. Okay. I think that's pretty fair because if Henry's over here bored out of his mind because I'm helping 5 kids who missed school, that's not fair for Henry. And I'm not going to do that because he's not the one who missed school. You missed school. So you need to make it up. Friday school. Friday school is, if you miss school, this is the time to come and catch up. You get Miss Harris. She's here. I'm here for a short period of time. I can help you. Okay? Infinite Campus, this is where you figure it out. You can figure out what you're missing on there. You can figure it out on Google Classroom. So AJ, did I help explain that answer? And you know what? And you asked a great question. And I'm not blaming AJ, because I know in 6th grade it was different. But 7th grade is very different than 6th grade. So my expectation is this, to get you ready for 8th grade. Today we're talking about this. We've already talked about it. How can I predict, how can I predict the sum? What's sum?
The sum is the answer.
Answer to a
Problem.
what kind?
Addition.
Nice. Zane got it. So, a little bit of help, right? So, the sum is the answer to addition problem. And we're going to figure out if it can be positive or negative. Just 2 numbers. And we got the algorithm chart to do it. Hey guys, remember to work on your reflection. That's what we're going to do right now. All right. This group. You guys are going to work on this board. I'm going to tell you what you're going to do in a second. You guys are going to join them. 2 people are going to be doing the writing. And I'm going to explain how that works. This group and that group, you're going to work on that small board. You all listen. You only need 2 markers.
Is it like what you showed us the example of?
You only need 2 markers, 2 people writing. So it's that group and this group. You guys are going to be on this board. And everyone's going to stand up and go to their areas. No one's going to stay in their seats. Next. Let's do it this way so everyone will get up. You guys are going to go over there. You guys are going to go over here. And then you guys go to the back. This is what we're going to do. We are going to practice writing a math reflection. But you're not writing anything down except on the boards. This is what we're looking for. This is the rubric. This is how I score your reflection. You need to answer all parts of the question. You need to restate keywords in your answer, or I need to change that. Employing full sentences and proper grammar and spelling. How funny. I wrote employing. And it should be employing. Use appropriate vocabulary. So when you're explaining your answer, think about the vocab. And then you're going to illustrate your answer. So the question you're going to do with your group, with everybody in your group, is this. How do you decide which of 2 numbers are greater when both numbers are negative? How do I decide which one is greater? You're going to answer that using this. And I'm going to tell you what the first group had the hardest time with. This one. All you have to do is restate that question, and you get that. And that's 1 point. Restate your answer, restate the question, and you get 1 point. So I want you to think about that in your group. There's markers over there. 2 people. There is absolutely 0 drawing. You can make a sketch. You can graph. You can chart. You can make an example. But no people. I already have a couple kids. I don't want to add any more. I got a ton of kids coming in. But beginning of the year, this is what happens. For a lot of things. Okay. You guys, do 2 groups. You're over there. Do 2 groups. That one. You guys, that one.
It's too much work.
You need 2 markers in everybody's brains. Everyone's working together. You need to write down your response. We got about... You can wheel over and just be on the side. Let's go. Let's get a response going. Talk as a group. Talk as a group.
Did I do like my homework and my exit ticket at the end of this class?
No, not at the end, because I'm getting ready for the next class. You got to come during your time. Missing school is it's tough. Okay? Now, maybe you could come right at the end of school. You can come at the beginning of school. You can come during lunch. Right? Okay, perfect.
Okay. So we have to answer all parts of the question. So how do we decide which two of the numbers are greater than both?
Who's writing the answer? I see someone sketching. Let's get the answer writing. You have to write. What's up?
Were we supposed to do this thing?
Yes.
Because I was confused and I was just going to come in at recess.
No, you don't need to do A. You need to do B. And that's what we're doing right
Were we
now.
supposed to do it?
No, Thursday. No, that's good, Ariana. Good question. Isaac, focus. Isaac, you're doing this, but you're not focusing. So you know what you just did? Added more time.
Paul, you're right. Both numbers are positive.
Jeez.
Answer all parts of the
You got 15 minutes now.
No.
When I see you're more mature, you won't have to do this, right? Come on. Don't worry about it. You worry about you. You worry about that.
Isaac's my buddy.
Well, he can tell you later. Where's your answer? You got to write it down, guys. Restate the question. Oh, yep. I'll go back to the slide.
How do you decide?
It's up there, guys.
How do you decide?
Wait, would that be restating if I go with how do? How you decide. Perfect. Then I could do how you decide.
Which of the
I had it like
You decide this by which. Woo. You decide what though? When you say this is where you have to keep restating.
oh right.
You decide which. Good. Just kind of go up like that. You decide which of the two numbers. Woo! That's real good restating. That's real good. How do you decide which of the two numbers are greater when both numbers are negative? Good. Now you've got it restated. Now you can answer it. Who's drawing the illustration or the example? Someone make an example. You decide which of the two numbers. So here you're saying -8 is greater than -7.
Yeah.
Who? Oh, but are we talking about absolute value? Are we? No. Yeah. We're not talking about absolute value right now, but that is super smart.
How does that make sense?
Because it's closer to zero.
Ready? Would you rather owe me $10 or $1? You would rather owe me $10?
I would rather owe you zero.
Okay. Right, now do you understand why that makes sense?
It's because it's closer
It's closer to zero.
And it's
-1 is a greater number than -10. You don't want to owe me -$10.
So when you're talking about absolute value,
Absolute value is different than this.
then you'd have to say,
Okay? So what's your example? It's going to show it. Oh, make those negative, right? That's way better. That's what I expect out of you, man. Are we talking about absolute value right now? Is that asking about absolute value? No. So,
oh wait, which one's greater?
we're not talking about absolute value right now. I love your thinking. How are we doing over here, guys?
Doing good.
I know, right?
That's one way to state it. So hey guys, they did something really cool over there. They said, and I like what you guys did, they're using a little bit more vocabulary. They said when the absolute value is the smallest, that is the greatest total value, right? Because that absolute value means it's closer to zero.
Yeah, that confuses me even more.
You don't have to do that. That makes sense, right? You can just see, no, but seeing which number is closer to zero, bingo. Are you guys almost done? Oh, you better hurry, Brennan. All right, guys, we are. Brennan, you keep writing, but I need your group to focus up here because you know what you're going to write. All right, here we go. So we're going to review. All right, because this is what this is for, Caleb. Excuse me. Thank you. So here's what this is the reason why I'm doing this. This is the rubric. This is how I'm going to score every single one of your reflection answers. This paper, right? You have 2 of them. I'm going to use this. How many points can you get total? 4. So, we're going to see how many points I give you right now on your work. So, over here, read your answer.
So we restated how you decide which of the 2 numbers are greater. And you said when both numbers are negative, you find which one has the least absolute value. And our example is that the negative number that has the most absolute value is farther away from 0. So then you can find out which negative is bigger, which negative is smaller, and the negative end that has least absolute value
Is greater. So here it is. Did they answer all parts? Yes. They talked about 2 numbers. And they talked about which one's greater. Okay? Next. Did they restate the question? Yes, they did. They said how you would decide which of the 2 numbers are greater when both numbers are negative. And then they answered it. Perfect. So they restated the question. And they got 2 points right now. Did they use appropriate vocabulary? They talked about greater. They talked about closer to 0. And they talked about absolute value. Perfect. 3 points. And they have an example that shows their understanding. They got a 4 out of 4. To the back. Kendall, go ahead and read.
Okay. Okay. You decide which of the 2 numbers are greater when both of them are negative by saying which one is closer to 0. And we did 7 and 8 as an example, and we said 7 is greater than 2 is closer.
It wouldn't be positive 7, it would be
Negative. Yeah.
okay. So, they answered all parts of the question. They talked about 2 numbers, -7 and -8. Right, Nathan? So they get a point there. They restated the question. All you have to do is take this, and it says, how do you decide? You could say, one way to decide, or how you decide. It's really easy. You get the restatement just by changing a tiny bit of this. Jaden, move away. I want Danny to listen. Instead of you whisper to her. Next, Jaden. Use appropriate vocabulary. They use greater. They use negative. They talked about being closer to 0. Bingo. Didn't use absolute value, but you don't necessarily have to. They get another point. And I look at their example, and it shows which one is closer. Perfect. All 4 points. Brennan, go for it.
In order to decide which negative number is greater, we must find out which number is closer to 0. Whichever one is closer is greater.
So again, answered all parts of the question, almost. The only thing I'm looking over here, I don't know which 2 numbers they're comparing. I see -5 and -20, but they don't tell me which one's greater. See your example? Nothing over there says that -5 is greater than -20, right? So, they illustrated, but did they answer the question? Not quite. So, they might get half a point or 0 points on that one. They restated the question, point, used appropriate vocab, point, and they get a point here. So, at best, that would be a 3.5, but I'd probably give them just a 3. So they get a 3 out of 4. You need to make sure that, bingo, now I know -5 is greater than -20. Perfect. So, the reason why I'm doing this, Hawken, is so you can be successful on Thursday on your reflection. Because this is how I'm going to grade your responses on here, using this rubric. Tomorrow will be slightly different. We're going to do another quick review. All right. Please go back to your seats, erase your boards, and put your notes in front of you.
Can I have a wheelchair? So I can take it to me back.
Right there. Take a chair and put it maybe up front. What's up?
Can I please use one too?
What?
Can I please use one of the wiggly chairs too?
Yeah, go for it.
Can I please do?
Yeah, as long as you're not twirling in it, right? Okay. All right. No. Your decision making has not been good today. All right. So here we go. On your notes, we're talking about adding and subtracting rational numbers. What's a rational number?
Isn't a rational number a number that's whole?
Ooh, that's an integer. A rational number is any number that can be written as a fraction. So it could be, this is a rational number, 1 1/4, right? 1.5 is a rational number. Okay, 1 is a rational number, but it's also a integer because 1 can be written as 1/1. So these are all rational numbers. So what we're looking at is rational numbers in trying to predict this pattern of what is going to be positive and what's going to be negative. So here, 5 plus 11 equals 16. Then what does negative 5 plus negative 11? So this is, the algorithm for this would be negative 5 is smaller in absolute value than negative 11. So I'm going to make this a bigger negative than that. And then what happens? Well, when I have a negative plus a negative, I get an even greater, in absolute value terms, negative. This is further from 0 than either one of those. So I know that a negative plus another negative equals a number that's further from 0. So negative 5 plus negative 11 equals negative 16. So it is almost just like the positive, except now my answer is negative. Because when I add a negative, what's that like? Subtracting a positive, we go left on the number line and values decrease. This value has decreased from negative 5 all the way to negative 16. That makes sense. This is what I'd like you to do. Using a similar model that I did, go ahead and do number 2.
So it would be positive n, so just n.
I forgot to grab that.
Or actually, yeah, small pencil. Maybe smaller n, right? Is negative.
You can take my notes, make sure you take the notes. You want to use that model.
And then for a bigger absolute value p that's positive, and then that equals positive, bigger positive. Here, look, negative 2 up there, positive.
So get down the algorithm. What's the algorithm that this is showing? Which algorithm is it?
Positive 11 equals 6, yeah. Positive 6.
So I know that 5 plus negative 11 equals negative 6. This 5, that is a small absolute value positive plus a large absolute value negative. So this absolute value, this is further from 0 than the positive. So what happens? My answer turns into a negative answer because the negative is further from 0 from the positive, so the positive gets canceled out. You remember the chips, right? In the chip model, that 5 disappears because the 11 cancels it out. there's definitely 5 in here. And so what's left over is 6, negative 6. So what is this algorithm? Athena, what'd you get for this algorithm?
I honestly don't know.
Kendall, you want to get these notes down, Athena.
Negative plus positive equals
So a negative plus a, whoops,
big positive.
plus a positive. Is this absolute value further from 0 than negative 5?
Yeah.
Okay. So because the 11 is further from 0, I'm going to make the p bigger with the lines. And that's going to equal a,
Positive.
but not, this is not going to be as far from 0 as at 11 because the negative is taking away from it. So then I would have negative 5 plus positive 11 equals negative, whoops, positive 6. That would make sense because if you think about the chips, if I have 5 red chips, are there 5 red chips in 11? Yes. Yeah, there's 5 black chips I meant. 5 black chips here, so they cancel out. So how many black chips are left over? 6. 6 black chips are left over. So you're going to be working on this today. Please turn your paper over. We don't have a lot of time today, but tomorrow is going to be a big day. We're going to have like 40 minutes of math time for you to do independent practice. But today, for the short amount of time we're here, you're going to be working on A1, A2, and A4. And don't this confuse kids, so I'm going to take that out actually right now. But just work on A1 through A4, read the directions. If you get done those, then you go to B1, B2. It is independent. Make sure you are practicing asking questions and checking your work. The answers are already up there if you want to know if you're right or wrong. Yes? It says find the sum, okay, in each group. So, what's the sum, what's the sum, what's the sum, what's the sum? So in number 1, you're finding the sum of each one of those number sentences.
Every group?
You find the sum of each number sentence in group 1, and you find the sum of each number sentence in group 2. Nathan, come on. A3 or A4?
A3.
Right, 2 new problems. So you see what they did. What's the pattern? You create 2 new problems using that pattern. Look at.
So 2 more for.
Yeah, for each group. Yeah. Good work. Nice guy. Nice work, Casey. Yeah, Riley.
I don't understand what it means by write 2 new problems. Do you mean like 2 number problems? Or?
Yeah, 2 number problems. And you can use different numbers.
Okay.
But just look at the pattern they did, right?
Mm-hmm.
So you could use 6 and 2.
Okay.
And just keep that pattern, right? And just show that you understand what the pattern is. Remember, guys, you can always check your work. Okay. Let's move this over. Let's try to get more organized in our thinking here. And you see how it's like way over here, right? So more organized would be like A1 would be here. And then we would start our writing here, not way over here. And then we go to A2, and we put A2, okay? Just try to use your paper space a little more wisely. All right, guys, I told you today was going to be short, but good news is I know we're going to get through this tomorrow. So, put this away. Get out your planners. So, with the planners, here it is. Planner. You're going to need to write this down because we are on page 44. We started a whole new section on page 44, and we're going to do number 3, number 4, number 11, and 14b. So you want to write this down. If you don't have your planner, write it down somewhere else. Today is September what? 10th. Good. So again, page 44, number 3, number 4, number 11, 14b. They're quick. They're not going to take you very long, guys.
15 minutes.
Okay, probably not even. If you think about the algorithms, no problem. Because that was our goal today. Can we predict the sum of 2 numbers, one positive, one negative? Yeah, I think we can. When we look at absolute value, that tells us whether it's going to be positive or negative. Oh yeah. Exit ticket. Write down an algorithm. We got about 2 minutes. Write down an algorithm that is finding the sum of a positive and negative number. Write a sentence explaining what the numbers represent in your algorithm. So, first thing, write down an algorithm that is finding the sum of a positive or negative number. Look at all the algorithms you can write down. But not all of those. This one's 2 negatives, that one's 2 positives, so those won't work. But those 4 do. And they all have a sum because I'm adding. Any of them.
And then do we just write a number sentence?
Yeah, and then you'd fill in the number sentence.
What does it mean, like, write a sentence?
Write a sentence explaining, like what is it? Like a smaller, a negative that is close to 0 plus a positive far from 0 is going to be a small positive. That would be your sentence.
This one, Cloud. The first one doesn't make sense.
This one?
Yeah.
A positive far from 0. Okay? Further from 0 than this negative, because that's bigger, right? It's like further from 0. Plus a negative. When I add negatives, it's like subtracting a positive. So I'm going to... Oh, it's the wrong color. That's what it is. Wow, nice job. It's the wrong color. work, Shafe. That's the first mistake I've ever made. I know, it's pretty impressive, I know.
How do you write a sentence?
I just explained. Explain what the algorithm means. So I want you to explain what the algorithm means. I'm going to change that for next class. Explain what that algorithm means. And then I know you'll understand it. Guys, remember, you don't need to finish it right now, but it needs to be done by Monday, next week. So you can do it tonight for homework. Take you 2 minutes, because that homework's only going to take you about maybe 10 minutes. You have a wobbly chair, mister. Come on. All right. Please replace your chairs. Push those chairs in. We'll see you later.
Bye, Mr. Farley.
See ya, Athena.